Hello everyone. Today we are going to see how to create a VPC in AWS Cloud, how to create public and private subnets, and launch EC2 instances in the public and private subnet. So in AWS Cloud, we have different regions and every region has two or more availability zones. So when you create a VPC, you create a VPC inside a specific region and you assign an IP address range which can be used for whatever you launch in that VPC. Then you divide this range into virtual networks called as subnets. And you can then define what type of access every subnet will have. So you define public subnets and private subnets. So public subnet is a subnet wherein if you launch any instance, it will have internet access, and from internet the instances launched in public subnet can be accessed. So to the internet and from the internet access is available in the public subnet, and in private subnet the access is not available to the internet or from the internet. So once you have defined this, then you can launch your applications, your servers. Say for example, you can launch a web server in the public subnet and a database server in the private subnet. Now when you create a VPC, apart from the subnets, there are few other components that are also associated and required. So there's a router which gets automatically created and which basically controls how the communication can happen between different subnets from the outside world to inside and from inside to outside. So basically our network to network communication will be happening via the router, and it will have something called as route tables which will define where to route the traffic. And apart from this, there are two types of firewalls. So security group is a firewall that is attached to an instance. So it controls access into and out from the instance. And similarly, there is a firewall at a subnet level or at a network level, which controls access into and out of the subnet. So what makes a subnet a public subnet? So just giving a name as public subnet, will it make it public? It will not. So primary thing is you need something called as an internet gateway, which you attach to the VPC, and then you define a route in the route table which is mapped to the public subnet, saying that any traffic which is not local or which is not for a specific IP within your network has to be routed to the internet gateway, because the IP addresses may reside on something which is outside your network. So two things, internet gateway and route to the internet gateway, makes a subnet a public subnet. Similarly, what makes a subnet a private subnet? So having no route in the route table to the internet gateway makes a subnet a private subnet. So you can see here there are two different route tables, one attached to the public subnet having route to internet gateway, and one attached to the private subnet not having any route to the internet gateway. Now if there's no route to the internet gateway, then whatever you launch inside your private subnet cannot access the internet, nor you can access that instance from the internet. But obviously for us to install something, maybe like patches, software, and do the configuration, let's say on the database server, you would need internet access even for your instances in the private subnet. So how do you do that? So to be able to have internet access, you need something called as a NAT gateway, which you can define or deploy in the public subnet. So because NAT gateway is in the public subnet, it will have internet access, and in the route table attached to the private subnet, you add a route to the NAT gateway. So this way, any traffic that you initiate that is destined for the internet from the private subnet will go to the NAT gateway, and from NAT gateway via the internet gateway it will reach to the internet. So this basically allows us to define how we can access the internet from EC2 instances in the private subnet. But first of all, to run any command on the database server, as an example, you should be able to log into the database server. You are sitting outside of AWS, so you would be accessing that EC2 instance over the internet. So how do you do that? Because we have secured our private subnet to not have access from the internet. So for that, to be able to log into your EC2 instances in private subnet, you can deploy another EC2 instance. Usually we call this instance as a bastion host or a jump server inside the public subnet. And then through security group rules, you can define that the bastion host, like basically any network coming from the bastion host, is allowed into the database server. So now bastion host works as a jump server. So from the internet, you log into the bastion host. From the bastion host, you log into your database server. So far, we have now established paths for the different subnets to have the necessary accesses. So we have defined the internet gateway so that the public subnet has internet access, and then we have also deployed the NAT gateway so that the private subnet can also have a secure internet access without allowing anyone from internet to access the private subnet instances. So this is only defining the path, making things available, but we need to secure. So how do we actually restrict this? So we can restrict this using two levels of firewalls. So which is security group at the instance level and the nexus network access control list at the subnet level. So usually if you see any NACLs that get created default when you create any VPC in AWS, they allow all incoming and all outgoing access is allowed by default. Okay, so everything is allowed. Uh, what you can do is you can create additional network access control lists, and then you can have a better control. So that is one way. The second level of firewall is at the instance level, which is a security group. So what we can do is, for the discussion that we had on the different types of instances like bastion host, servers in the public subnet, servers in the private subnet, the way you can define security groups is allow internet traffic or source as internet and destination to be the bastion host, and allow port 22. So 22 is for SSH. So whenever any admin wants to log into any of the servers on Linux, they use SSH. If it's a Windows, then they use the RDB port, which is 3389. So consider these are all Linux instances. So we'll open a port 22 in the security group attached to the bastion host, allowing incoming port 22 from in the internet. Okay. Now from the bastion host, we want to be able to log into the database server. So again, we will define an incoming rule, inbound rule, to allow port 22 from the bastion host or the security group attached to the bastion host coming into the database server. And because our web server, which has the web application, needs to connect to the database server, we'll also define a rule from the web server or the security group attached to the web server coming into the database server. So here port is 3306 for MySQL. Okay, so we'll allow 3306 in the inbound rule in the security group of database server. Now to log into the web server, you have two options. Either allow an access coming from the internet on port 22 on the web server. However, this is not a very good practice. So instead of this, what we can do is we can use the same bastion host and allow only traffic from the bastion host into the web server on port 22. So this way now we have secured the accesses to the subnets through the necessary gateways and accesses to the instances via the security group rules. Now, do you need to create VPCs right from scratch? So not really. So when you create an AWS account, A default VPC is automatically created by AWS for you in every region, and it is assigned this specific IP address range, which is 172.168.0.0/16. And this IP address range is then divided into subnets. So again, you have default subnets. So there will be one subnet per availability zone, and there's an internet gateway defined. There's a route table attached to all these subnets, and there will be a route to the internet gateway. So in short, all the subnets that you create over here are public subnets. Right? And then there's an NACL, default NACL, and a default security group also defined. Now, it's a good practice to not use the default VPC, although you can, and it's not a security issue. You can use default VPC. You can customize, you can add more security groups, define rules, what is allowed, what is not allowed. You can create private subnets inside your default VPC also, or you can create your own custom VPC subnets inside that NACL security groups and so on. So this is what we are going to create now. So we will see how to create a VPC inside AWS Cloud, how to create public and private subnets, and in order to do that, how to deploy an internet gateway, an ad gateway, how to define route tables, and then we will launch EC2 instances. So we'll launch a Bastion server in public subnet, a web server in public subnet, and a database in a private subnet. And then we'll control the accesses into and out of these EC2 instances via a different set of security groups. So we'll have different security groups for each type of accesses. So I logged into AWS and I have come to the VPC console. So and currently I'm in the Mumbai region. So as you can see, by default, there are few things already available in Mumbai region. Similarly, if I go to any other region, you will see a default VPC, some subnets in that VPC, NACL, internet gateway, route tables, and security groups. So there will be one VPC in every region, and depending on that region, how many availability zones there are, those many number of subnets will be created inside that VPC. So for example, if I go to North Virginia, which has some 6 or 7 availability zones, there will be those many subnets created. Okay, so now there are 9 availability zones within North Virginia, and there are 2 VPCs, it seems. Okay, so um, you can start using the default VPC and then you can start launching instances, but there you only have public subnets. So whatever subnets come by default are public subnets in the default VPC. If you need private subnets in your default VPC, you will have to create those. So now we are going to see how to create custom VPCs and how to create all these components. Okay, so there are two ways. One is using the VPC wizard, which is a very simple way. So you just click on the VPC wizard and then you select what type of network do you want to create. Do you want to create just a single VPC and a single public subnet? Do you want to create a VPC with one public and one private subnet? Do you want to create VPC with public private as well as VPN connection to your data center and so on? So in this, if you go, it will ask you for some details, and if you create, it will create all the necessary components including the VPC, the subnet, the internet gateway, the route table, and everything. We'll do it slightly in a lengthy way so that you understand all the components, all the steps, how we achieve this. So you can go to VPCs, your VPCs, and then click on create VPC. Here you can give some name for your VPC. So let's say I give my VPC1 and specify the IP address range. For example, I select 10.1.0.0/16. So sorry, /16. So this is going to give me 65,000 odd IP addresses for this entire VPC. And then we define the tenancy as default, which is the shared tenancy or dedicated tenancy. So we'll define as the default tenancy and create a VPC. One more important thing about the VPC is that when you launch EC2 instances, should they automatically have DNS resolution and DNS host names? So should they get host names, private host names, and should they be able to resolve any names on the internet or inside the network via internal DNS resolution? So if you want to enable this, then you can go and edit the properties and then edit, say for example, edit DNS host names, and you enable this. Okay, so ensure this is enabled. You enable both the DNS resolution and the DNS host names. Okay, so this is about the VPC. Once you have created the VPC, now you can start creating subnets inside your VPC. So go to subnets, click on create subnet, select the VPC in which you want to create your subnet. You can give some name to the VPC. So I'll say now this is going to be my public subnet inside my VPC1, and I will attach the subnet to availability zone 1A. So you can attach a subnet to a specific availability zone, and then you can define basically what IP address range you want to allocate to this subnet. So this will be a portion of the IP address range that you have assigned to the VPC. So VPC range you will divide into subnets, and each having a part of the IP range, and click on create subnet. So I've created a subnet, called it as public subnet. I'll create one more subnet and call it as my private subnet. And again, I will map it to the availability zone 1A and give it an IP address range, the next IP address range, and click on create. So now I have two subnets created. In my VPC1, public and private. There are two settings, or rather there's one setting that we need to enable for the public subnet specifically. So if I select the public subnet, you will see that the auto assign public IP address is set to no, meaning if I launch an EC2 instance, by default it will not get any public IP address, although I'm launching it in the public subnet. I want to change this behavior. So to do that, I will select the subnet, go to action, and in this edit the subnet settings, and I will enable the auto assign public IP v4 and save this. Okay, so now if I check again, now the auto assign public IP v4 is set to yes. For private subnet, we don't need to change this setting because anyway we do not want any public IP address. So public IP address is an internet accessible IP address. So we do not want any such public IP address for the EC2 instances that will launch in the private subnet. We want that only for the public subnet. So this is the last setting that you will have to ensure from the subnet perspective. So just naming the subnets public and private don't make them public and private. So what makes a subnet public? There should be an internet gateway, and the route table attached to the public subnet have a route to the internet gateway. So first let me create an internet gateway. So you can see there's already one which is attached to the default VPC. So I'll create one more and then I'll attach it to the new VPC. So I will say my VPC1 IGW, and after creating this I will attach it to my VPC. Okay, so this is one part of making a subnet a public subnet. So now we have an internet gateway. Now I need to add a route in the route table attached to the public subnet and add a route to the internet gateway. So let's first check how many route tables are there. So there's one route table, default route table, which is for the default VPC, and when I created my VPC, another route table was created by default. And if I check what are the routes defined here, you'll see there's only a local route, okay, which is able to route the traffic within the VPC itself. So here I will add one more route, and so any traffic which is not local, so 0.0.0.0/0 means for a traffic that is destined for any IP address, okay, which does not match this, basically route it to the internet gateway that we created. Okay, now we have defined a route table, but this route table should be attached to our public subnet. So we'll see if there are any subnets associated with this route table. So currently there are none. So what we'll do is we will attach our public subnet with this route table. Okay, so now if I go to the public subnet and see the route table, we will see it has a route table which has two routes. One is the local route, which will be there by default, and one has a route which is pointing to the internet gateway. So now we really have a public subnet. And similarly, if I have a look at the private subnet and see at the route table, it is also attached to the same route table. So what we now need to create is we need to create a separate route table for the private subnet, and there we should not have a route to the internet gateway. Only then this will become a private subnet. So I'll go to route tables and create one more route table. So I will call this as my VPC1 private route table, and I'll say create this route table inside my VPC1. Okay, so whenever you create a route table, it will automatically have a local route, and that's what we need. We don't need any additional routes because we don't want any route to the internet gateway. So now this is the route table that we will map it to our private subnet. So I'll go to the subnet associations, edit subnet associations, and click on private subnet and save. So what this will do is this will disassociate the previously attached route table which had the internet gateway route, and instead this private route table will be attached to the private subnet. So if I go back to the subnets and now see the routes in the private subnet, we see it has only the local route because we have created a different route table for the private subnet. We have a different route table for the public subnet. So if we take a look at what we have completed so far, so we have created a VPC and given it a range, and then in availability zone 1A we have created a public subnet, given it a range, created a private subnet, given it a range, create an internet gateway and attach to our VPC, and then we have defined two route tables, one for the public subnet having route to internet gateway and one for private subnet having a route to the so we are yet to do this. So for this we will first create a NAT gateway, and then we will create a route table and define a route to the NAT gateway. So now I will create a NAT gateway. So NAT gateway is chargeable. All the other components like VPC, subnet, internet gateway, route tables, these are not chargeable. So for the part of the demo or hands-on, create a NAT gateway. You will also need an elastic IP address attached to the NAT gateway, and after you're completed with the hands-on, you can delete the NAT gateway as well as release the elastic IP address, else you will continue to be charged. Okay, it is not available under the free tier. So I'll create a NAT gateway, give it a name, my VPC1 NAT, and the NAT gateway you have to deploy in a public subnet. So currently I have created a public subnet in availability zone 1A. So I'll choose that, and then I need an elastic IP address. So right now I do not have any. So I will have to allocate one IP address. So I've got one IP address, and now I can attach it to the NAT gateway. So it got created and it got attached. So I'll create this NAT gateway. So it takes some time for the NAT gateway to become active. So usually it will be in a pending state for a couple of minutes. So I'll just pause for till it becomes active. So now the NAT gateway is available. So we already have a route table for our private subnet. So we'll simply go to that route table and add a route that is for 0.0.0.0/0 to go to the NAT gateway. Okay, so I'm going to add a route to 0000 and route it to the NAT gateway. Okay, so now if we see what we have completed, we have now created a NAT gateway also, and in the route table attached to the private subnet, we have added a route to the NAT gateway. So with this, what we have established is we have a subnet, a public subnet, in which we can launch EC2 instances, and from the internet these EC2 instances will be accessible, and from the EC2 instance also it will be able to access the internet, right? So this is one thing. And then we have also created a private subnet, and we can launch EC2 instances in this private subnet. It will not be able to accessible via the internet, so there won't be any internet access into the private subnet, but we want access from the EC2 instance going out to the internet. So this we have achieved by creating a NAT gateway and defining a route in the route table via the NAT gateway. So now the EC2 instance via the NAT gateway, via the internet gateway, will be able to access the internet. So we have done this so far. Now we'll go and create EC2 instances and the necessary security groups. Now we'll launch the necessary EC2 instances. So I'll go to the EC2 console while staying in the Mumbai region, and I will then click launch instances. So first I will launch the Bastion server. I'll choose the Amazon Linux 2 AMI for my Bastion server. Now ideally Bastion server operating system is an hardened operating system, so you keep only the required users, you remove all the unnecessary software and packages, you ensure only limited services are running, and you allow only restricted ports like port 22 coming into the Bastion host and so on. So for now I will use the default AMI. I will not customize it, but if you're doing it for production, you need to harden the operating system. So now on this next page, I will choose my VPC1. So I will launch this EC2 instance inside this VPC in the public subnet. Okay, because this is a Bastion server, I need to select this as a public subnet. And you will see, because we had set the auto assign public IP for our subnet as yes, an IP address will automatically, a public IP address will automatically get assigned whenever this instance launches, and only via public IP assigned to an EC2 instance, it will be accessible over the internet. So just launching an EC2 instance in public subnet again is not enough. It also needs to have a public IP address. Click on next, add storage. I'll keep this as default. In the tags, I will add the name tag and give it a name Bastion. Now in the security groups, I will create a new security group for this. I'll say Bastion SG, and in this I will allow any traffic coming from, so for now I will be allowing any traffic coming from the internet on port 20, port 22 SSH. This is what I will allow. In a real scenario, live scenario, you may want to restrict any access coming only from your data center network. So in that case, if you have data center network connected to your Amazon VPC using either VPN or direct connect, you will give that particular IP address range. So for now, I will keep this as anywhere. So any internet traffic can come into the Bastion host on port 22. Click on review and launch, then click on launch. And now you can choose, you can either create a new key pair if you don't have one, or if you already have, then choose an existing key pair. So I already have a key pair. That's what I'm going to select. And then I'm going to launch the EC2 instance for the Bastion host. Now, while the Bastion host is coming up, I will parallelly also launch the web server and the database server. So I have a sample web application which is developed using Apache, which runs on Apache web server using PHP and which can connect to a MySQL database. And this application runs on Ubuntu. So I'm going to choose Ubuntu as my operating system. So I'm going to select the Ubuntu AMI 20.04 for my web server first. I'm going to keep the size as T2 micro, that being the free tier available. Again, I'm going to select my VPC and the public subnet for my web server. Again, here it will get a public IP address based on the default setting of the subnet. I will keep all the rest settings as same. I will give it a name as my web server. And now in the security group, I'm going to create a new security group for web. Okay, so any web servers can use this security group. And in this, I'm going to allow port 80 coming from the internet. Okay, so I'm going to allow only port 80, so which is HTTP coming anywhere from the internet. So I'm not allowing port 22 here straight away. So what I will be doing is I will add that once the instance gets launched. I will show you how we will be adding those rules. So for now, I will keep only the HTTP rule, and I will again select my key pair and launch this instance. And again, while this instance gets launched, I will also launch the database server, again selecting Ubuntu as my AMI, T2 micro as the size, selecting my VPC one. This time, because this is a database server, I will be selecting the private subnet that I created. And as you see, the default subnet setting is to not assign any public IP address, because we don't want any internet connectivity anyway. So again, I will keep this disk size as default and give it a name as my DB server. And again, I will configure a new security group for my database. And here I will choose MySQL as the port. Sorry. Okay, which is 3306. Now here you can either specify from a specific IP address, or you can also choose a particular security group. So right now I'll keep it as this. I will later on edit this. Let me launch the instances first. I will later on edit the security group again, and I will show you what changes I am going to make. So again, select the key pair and launch the EC2 instance. Okay. So what we have now achieved is basically we have added this 3 servers, right? So we have done this, and we are almost done with this with a few exceptions. So I'll be adding few more rules, and that's what I'm going to do now. So let me go to the security groups. So it's available under EC2. It's also available under VPC. So I'll go to EC2, network and security, and the security groups. So in this, these are the ones that we created. Sorry. So WebSG, database SG, and the Bastion SG. So what I want to do is the SSH connection into web server, web and database. I want to allow it to be coming from Bastion security group. So I'm going to edit this. And in the inbound rules for the web server, I'm going to add SSH, and this I'm going to keep it to be coming from the Bastion security group. So this way, instead of giving the IP address of the Bastion server, I am allowing traffic coming from any EC2 instance which is attached to the Bastion security group. so that in future also if I add more Bastion hosts, I don't have to keep on adding rules to all my servers to allow traffic from each and every new Bastion host. Okay, so this way the configuration is kept very simple and still flexible. Okay, in a similar way, I will update the database security group inbound rules, and I will add SSH coming from the Bastion SG security group. Okay, and for the Bastion security group itself, so I have allowed SSH coming from anywhere from the internet. Like I said, you could restrict this to come from your private IP address. Okay, so if you want to allow only from the data center, here your aim is to allow from anywhere from the internet so that the support team can access it remotely from anywhere, then you can keep this as it is. Okay, so we are done with the security group configuration. We are done with the EC2 instances configuration. So now let's try to see whether everything works. So first I will try to access the Bastion host from the internet, so from my laptop. So because I'll be accessing over the internet, I will need the public IP address of the Bastion host, and I will use putty. And because I have launched the Bastion host with the Amazon Linux AMI, the default user is EC2-user. So I will say EC2-user at the rate and the IP address. And I have already configured the SSH key pair. So you can do that if you are using putty. Then go to connection SSH auth and then browse the PPK file. So if you don't have the private key in the form of PPK, you can use putty-gen. And again, I have explained this in the video for EC2 instances demo. So you can watch that to understand how to convert a PEM file into a PPK file. So I'll accept this, and okay, so I think I had changed the location of my file. So let me remap that. Okay, so now I think it should work. Right. So now I have successfully able to log into my Bastion host. Now from the Bastion host, I want to be able to log in into the web server. So before that, we have not enabled SSH from the internet into the web server or the database server. So I'm just going to try whether I am able to log in. Okay, so now because the web and database are the Ubuntu AMIs, the user in Ubuntu AMI is Ubuntu. And you will see that this session completely hangs. Okay, so it is not responding. So I'm not able to log in from the internet using SSH into the web server. Similarly, now for the database server, anyway, we don't have any public IP. So it is anyway not accessible from the internet. Now let's check from the Bastion server, are we able to log into the web server and the database server using SSH port? So for that, what I need to do is, I need the key file that I had downloaded. Okay, so which is in the PEM file. So I need this file contained into my Bastion server. So I'll just open this file. And I'll do Control A, Control C. So copy the entire contents. And in my Bastion server, basically, I can create a file. Okay, I'm using the VI editor. You can also use the nano editor. So say VI, give the file name, press enter, and simply press I key and then paste the contents. Okay, no extra keys, no extra characters, just I to insert and then paste the contents. then press escape key colon WQ to save the file. You can also use the nano editor if you are more comfortable with that. So let me open a different file, and here also you can then paste the contents. If you are using a nano editor, to exit you can write Control X. It will ask for a file name, and then you can give the file name if you want. It asks you whether you want to save the file, so just press Y and enter. So if you are using nano, this is the way you can save it. Now once you have created the file, we need to change the permission because this is a very sensitive file. We need to make it only read only. So if I just check the current permissions, you will see it is read write and read write for the user and for the group, and read for anyone else. So this is how permissions in Linux works. So I'm going to change it to 0400, and I'll show you the difference. So now it's only read permission only for the user and no permissions for the group or for others. So this is mandatory, this is required for any private key file that you create. Now what I'm going to do is I'm going to take the IP address of the web server. Now because, okay, so I think I got logged out. Okay, so because the Bastion host is already in the VPC, to access the web server and database servers, I don't need any public IP. I can use their private IP address as well. And because there was a local route in the route table, the AWS VPC network can route any traffic within the VPC with the help of the local route. So now what I'm going to do, I'm going to use the SSH command, specify the key pair, and say Ubuntu @ and a private IP address. And you can see I'm able to get into my web server, right? So now I will make this web server ready. So I will update the packages on the web on this EC2 instance. Now I will install the necessary packages for Apache and PHP. And because PHP will also need to connect to MySQL, I'm going to add one more package called as php-mysql. So I'll install all these on my web server. Okay, so now I've installed the right packages. Now what I will do is I will install some code that I have in a particular repo. So let me just check where. Okay, so the repo is this one. So let me clone this. So let me go to /tmp, and there I will clone the contents of this GitHub repo. And if I go to web pages, I have a code for 2-tier application, okay, inside web app. So I will copy all this code to var www.html. Now I need to be root to be able to do this. So I will do sudo move. Okay. Now I have deployed my web code into var www.html. Now what I need to do is, if I just open one of the files, in this I have a code to connect to the MySQL server, and using the host name of wherever I'm going to install my SQL Server, and with this username and this password and with this database. So because the database server is a completely different server, let me get the IP address of the database server and change the code, and wherever it says localhost, I am going to replace it with the IP address of the database server. And I have this code in few of the other files also. So through command, I'm going to use the sed editor, serial editor, and I will just use this syntax to replace localhost with IP address. Okay. Okay. So I need to do it with sudo. Okay. So now if I just open one of the files, we see that IP address has been updated. Okay. Uh, so this is done from the web server side. Now I need to prepare the database server to have the necessary MySQL installed and to create the necessary tables and all. So I will exit from this EC2 instance. So now I am back onto my Bastion host. Okay, so if you see, I'm on 10.1.0.5.0.45, which is the Bastion host IP address. So now from the Bastion host, I will log into my database server again using the private IP address of my database server. Now again, I will update the system packages. And on this server, I want to install MySQL software package. So MySQL server is the package I'm going to install. And now, as you can see, although the database server is in the private subnet, we are able to access the internet from the database server. So that is because we created a NAT gateway, and the route table attached to our private subnet had a default route pointing to the NAT gateway. So any internet bound traffic will be sent from this database server over the network, over the private network into NAT gateway. From NAT gateway, it will go to the internet via the internet gateway, because NAT gateway itself is in the public subnet. Okay, so now MySQL server is installed. Let me edit the configuration file. Okay, it's not this file. conf.t. Okay, so let me change to root. Okay, so in this file, there will be an IP address defined saying that the server will be listening on this particular IP address. So this is a local IP address 127.0.0.1 is a local host IP address. So meaning it will be listening only onto its own IP address, its localhost IP address. It will not be accessible from the outside network. However, we want this MySQL server to be listening and running on an IP address which is the private IP address of the database server. Or I can change this to listen on any port on this database server. So tomorrow if I add few more ports or IP addresses on this database server, I want MySQL to also listen on those IP addresses. So I'm going to change this and then I'm going to restart the service. Okay, so now MySQL is running. Now I need to create some users and database and tables into this database so that my application can work. So for that I am going to connect to MySQL database as a root user and I'm going to run a few commands. So I'm first going to create a user with the name user1 identified by password as password. Okay, so obviously in production you will go for some complex passwords. So I'm creating a user1 which can listen, which will accept connections on localhost as well as from any IP address. Now I'll create a database called as test2 and inside this database, I'm going to create this table called as persons. Okay, and this persons table will have all these columns and I'm then going to give all permissions to the user1 on this test2 database tables. Sorry, so I need to copy this. Okay, similarly I'll give permissions to user1 on the local host. Okay, so now I have created a database, I have created the necessary users, created a table and given necessary permissions for user1. So if you remember, the code that I shown was using a user1 as the username and password as the password and connecting to the database called as test2. So we have completed all this. I hope I have done all the necessary configurations. Now we can check whether the application works or not. So for that, I will go and fetch the public IP address of the web server. And because our application is running on port 80, I'll simply give the IP address. Okay. So one more thing remaining. So I can also so what happens is when you only open or when you only connect on HTTP, it looks for a file called as index.html. So whenever we install Apache, by default there's an index.html, whereas the application that I have is actually PHP code, so it uses the file path called as index.php. So if I want to have this default behavior, what I can do is I can delete the default HTML file. So I can log in back to my web server, change to root, go to where www.html, and here I will remove the index.html, which is the default file which I don't want. And now if I simply give the IP address also, it should work, right? So now our application is working, right? So this is just a sample application to take in some data and load into the database. So now we can see that the web server is also talking to the database and these entries are being made, right? So because we allowed port 3306 from the web server into the database, so that's how these entries are being made. So I think I remember something. If let me also go to the security groups for the database. Right. So I think I'd allowed from everywhere. So now let me restrict this to come only from the web server. Okay, so that we'll have our final configurations in place. So right now 3306 is allowed from anywhere on the internet, but rather I want it to be allowed only from the web server security group. So I will just modify this. Okay, so I think I need to delete this and add a new rule. Okay, coming from the web server security group. Okay, so let me test it once more whether it's still working, and it's working. So now I have restricted access to the database on port 3306 only from the web server. Okay, so our final aim is accomplished, and now we have completed all the tasks that we started with. So now that we have completed the demo, we have completed the hands-on, let's do one very important thing, which is to delete and clean up whatever we created. So I'm going to delete all the EC2 instances. So go to instance state, terminate. Okay, so all the EC2 instances are now terminating. So I'm going to delete everything that can incur a charge, although it might be available in free tier. Okay, so I'm deleting all the EC2 instances. Similarly, if I go to VPC, the important thing that you will need to delete to stop incurring any charges are the NAT gateway and release the elastic IP address which is attached to the NAT gateway. So first I will delete the NAT gateway. And it takes some time for the NAT gateway to get deleted, and only when this happens then I can release this elastic IP address back to AWS so that they stop charging me with this elastic IP. So I'm going to pause this video for a bit and then come back. Okay, so now the NAT gateway has been deleted. Now I can go to the elastic IP addresses, select the elastic IP that I want to return back to AWS, go to actions and click on release the elastic IP address. So now all the chargeable components within AWS we have deleted. We have deleted the EC2 instances and we have deleted the NAT gateway and the elastic IP address. Now you can choose to keep the remaining components like the VPC, the internet gateway, route table, subnets. That's okay because AWS does not charge you for these components. If you want to clean up, you can delete that also. So this has been a very long video, I know, but there were a lot of concepts that we covered. So we saw the VPC, the different subnets, what are the different components in a VPC, what makes a subnet a public subnet, what makes a subnet a private subnet, how do we provide internet access, outgoing internet access to private instances in private subnet. Similarly, how we can access the instances in private subnet by using a bastion. So we have seen all the connections, all the rules, the route table rules, as well as the security group rules. So hope you learned a lot from this video. Thanks for watching.